of my favorite lessons. So we are talking about right triangle trig today, and you've learned all of this. You've learned trig in geometry, okay? But in geometry, they just give it to you. Say, here's what it is. But I insist on you understanding why. Because when I took trig, I was like, I just don't get it. What is sine? I don't understand. What is sine? It just didn't make sense to me, okay? So I want to make sure that you're all understanding the why and the how of it. You do not have to write off. Don't. Hey, you do not have to write all this down. You do have to draw the picture. All right, so this is what? I'm recording right now.
Is this example?
I do have it on video.
No, do you have a dog? Yeah.
I did, yes.
Oh.
Wait.
Amanda and her dog Cleo, that's me, are standing in the shadow of a tall flagpole. Here is the tall flagpole. So I'm going to go ahead and draw a flag.
It's a good flag. Also, is this example one?
Nope.
That's a good country too.
Okay. All right, so there's the tall flag. And ladies and gentlemen, I have a question for you. If that's the tall flagpole, where is the shadow? Is it this or is it this?
It's the thing on the ground.
It's the thing on the ground. Thank you. It is the thing on the ground because that is where you see a shadow, right? You see it on the ground. So this is the ground and this is the shadow, which means there's a sun. Where is Mr. Sun? Over here. All right, to produce a shadow this way, the sun must be on the opposite side. So here we have our sun shining down and we've created our shadow. We can assume that our flagpole is standing square to the ground, okay? Perpendicular to the ground. The top of Amanda's 6.5-foot shadow. So here's me.
6'6".
My shadow is 6.
You're either a really tall person or
No, it's my shadow, not me.
yeah, but look at the flag and then you.
So here's my, okay, so the picture is not to scale. Okay. All right, so there's me.
Okay.
And then I've got my leash. And here's my dog, Cleo. Cleo is the coolest dog.
What? That's not.
My brother picked her up on the side of the road. She was chained up to the guardrail on, yeah, it was horrible. He rescued her from the certain death. Chained up to the guardrail on I-5. Right.
Yes.
She ran away down.
My brother found her chained to the side of the road. So we stopped and picked her up. All right, so anyway, Cleo was a totally cool dog. Let's see. The top of my 6.5-foot shadow matches the top of the shadow of the flagpole. So right now, right at this moment in time, my shadow is lined up exactly with the shadow of the flagpole. And my shadow is 6.5 feet. And let's see. If Amanda is 10 feet from the base of the flagpole, where is the 10?
It's in between you and the flagpole.
Yeah, so between me and the flagpole, I'm 10 feet from the base of the flagpole. All right. And Amanda is 5.5 feet tall, so my height is 5.5 feet. That's true. All right. So how tall is the pole? We want to know this distance. I'm gonna just call it the height, I guess. I'm just gonna call it H for height of the flagpole. How tall is the pole? Ladies and gentlemen, how do you figure that out?
Geometry was the original.
No,
That's area.
this is something we learned in geometry, right? And I don't.
You should have learned it.
Oh yeah.
We haven't taken this. This is like sine cosine.
So
Ratios.
Hold on.
Ratios. Very good. So I have a question for you. In that original picture, how many triangles were there?
3. 4. Oh no, there's 3.
Okay, there's one little triangle,
And then one medium.
a medium triangle, and then the big triangle. Those are 3 triangles. And those 3 triangles okay, have a few angles in common. So I stand up straight, perpendicular to the ground, and Cleo was also standing up straight, perpendicular to the ground. So we all have these 90-degree angles, and we also share this angle of elevation to the sun. Okay. Also known as these triangles are what are called similar triangles. Very good. Similar triangles. When we have similar triangles, they all have, the angles are by default all the same, but their sizes are not, but they are all proportional. So we can write proportions. So if I want to figure out the height of the flagpole, I can compare it to what I know about myself. My height to my shadow would be proportional to the height of the flagpole to the length of its shadow, 16.5. All right, how do you solve that? Cross multiply. So can I just like multiply the 16.5 over?
Yeah.
Can I just multiply the 16.5 over?
What that means.
Yeah. So, okay, do I need to show all of this?
Oh, no, it's 90.7.
So you did 5.5 times 16.5?
Yeah.
Okay. And you got 9, and then you got to divide by 6.5.
13.9.
Okay, so H is 13.96, yada, yada, yada. Okay, good. Yada, yada, yada. Goes on forever. So the height of that flagpole was just about 14 feet tall. Probably pretty accurate. All right. Okay, so then I want to know, how tall is Cleo? If Cleo's shadow is 2 feet long, so her little shadow right here is 2 feet long, and also is lined up and matches the top of our shadows as well. So I want to figure out Cleo's height there. So how could we figure out Cleo's height? All right, yeah, we could use either one. I'm going to stick with mine because I had some pretty nice numbers there. So 5.5, my height to my shadow is going to compare to Cleo's height to Cleo's shadow. Very good, over 2 feet. And then again, if we want to isolate the C, all we have to do is multiply the 2 over, right? All right, so 5.5 times 2 divided by 6.5 gives Cleo's height 1.69, yada, yada, yada. All right. So Cleo was not quite 2 feet tall. 1.69 feet. Okay. Well, that's all really well and interesting. And so similar triangles are very cool because if you know just a little bit of information, like my height and my shadow, I can find the height of a building. I can find out the height of the tree. I can find all kinds of heights, right? Because they're all similar triangles. And that's really important. Okay. So, but we want to look at these side lengths a little more closely. We're going to compare the heights to shadow lengths. So let's start with me. So I want to compare my height to my shadow length. My height was 5.5 and my shadow length was 6.5. That ratio turns out to be 0.84. 615 dot, 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 dot. Now I want to compare the flagpole. Let's compare the flagpole. What was the flagpole's height?
13.96.
A 13.96, yada, yada, yada. 13.96, yada, yada, yada. To the shadow?
16.
Okay. So I'm going to call that up actually because I have it in here somewhere. Let's see. Oh, there it is. 13.96. I'm going to grab that whole big long chain there and divide it by 16.5. Just arrow up.
I mean, yeah.
No, you just arrow up and go grab it. Hey, look at that. Those are the same, yeah?
Whoa.
Whoa. Whoa. Whoa. Okay, wait a minute. Let's look at Cleo. What was Cleo's height? 1.69 something or other to her shadow? 2. Okay, let's see. I'm gonna go again and grab that 1.69. So there's that 1.69 figure divided by 2.84. What? So 0.84615. They are all the same. Holy mackerel. So somebody many years ago, okay, realized that when we have similar triangles, if you compare the height to the shadow length for any size triangle, that ratio is the same every single time. So not only is it the same for height to shadow lengths, but it would also be true if I looked at height to hypotenuse ratios. The height to hypotenuse ratio of all of these similar triangles is the same every single time. It's the same if I compared the shadow to the hypotenuse. That ratio is the same as this shadow to this hypotenuse every single time. So when we have similar triangles, when I compare the different legs, those ratios are always the same. It's crazy for any kind of similar triangle. So those ratios we call trig functions. So this is the important part. So because someone noticed that the height and shadow ratios match, they said, let's give it a special name. Those special names are what you know: sine of an angle, cosine of an angle, and tangent of an angle. Those are the names that tell you which sides of the triangle to use. Okay, so what is the thing that you remember from geometry?
Toa.
SOHCAHTOA. You need
Well, I know it's
Alright.
sine is 0 equals 0.
SOHCAHTOA. SOHCAHTOA. You should write that down. I like writing it this way. SOHCAHTOA, because you can see the ratios.
Yeah. Oh my god, that was.
All right. SOHCAHTOA. All right. So first of all, this is point XY. XY is a point on the terminal side of angle theta. This is angle theta. Angle theta happens to be in standard position. So this is my initial side and my terminal side. Here's my little angle theta. It turns out the most important part of trigonometry is the angle. If you don't have your angle labeled, then you've done it wrong. You have to know where theta is. So what happens is, this is a point, an ordered pair on this terminal side, and we drop this altitude thing. We're going to get really used to dropping an altitude. And what we create then is this distance. Now we are on the XY plane, so we're traveling to the right, X units, and we're traveling vertically, Y units. Does that make sense to you? To get to my point XY? Okay. So X units to the right, Y units vertically, and we land at our ordered pair XY. Okay. We have this altitude, so we get always this right angle. Really important. We have a right triangle. Now, what's really interesting is I can move this point. So I could put this point right here. And if I drop that altitude, it's going to have the same ratio, exactly, because it's similar triangles, right? Yeah. Okay. So that point could be anywhere on that terminal side, and I'm just creating more and more similar triangles. So these ratios are always going to end up being the same. Good job. Okay, so now we need some labels because you know SOHCAHTOA. What does the O stand for? Opposite. And H stands for hypotenuse. And A stands for adjacent. Okay, so we want to be able to label those sides of our triangle. And the first one should always be the hypotenuse. Where is the hypotenuse? Over here. Yes, here's our hypotenuse. Hypotenuse is always opposite that right angle. So that's one you're going to find first all the time. So how do you determine the opposite side? Of theta. Yeah, so that's why theta is so important. We can't figure out what the opposite side is unless we know the angle that we're looking from. So the opposite side is here. Opposite our angle theta. Adrian.
So do we care, like, if theta is at the 90 degrees?
Theta will never be the 90-degree angle.
Okay.
Yeah.
I remember asking about that. People
It's
so
no, you just
like a 1 and 0 or something.
Yeah, we'll do that, but it's not for the picture that we dropped. Okay, so that leaves adjacent on the other side. And so we have X for this leg length, Y for this leg length. I'm going to call the hypotenuse R. R stands for radius because soon we're going to put this circle into this angle into a circle, and it becomes the radius. So I'm just calling it R for future reference. So if I want to find the sine ratio, thank you very much. If I want to find the sine ratio, then that would be the opposite over the hypotenuse, which based on the letters that we have, that would be Y over R. Okay? And if I want to do the cosine according to angle theta, so you should always say it that way. It makes a big difference. The cosine ratio according to angle theta would be adjacent over hypotenuse, X over R. Very good. Tangent according to theta is going to be opposite over adjacent, which would be Y over X. Very good. Okay. So first of all, you should know that this is sine with an E. It's important that you know how to spell it. It's not sin. It's sine. It really drives me nuts when people say sin theta. No, it is not a sin. It's sine. Okay. This is cosine. All right. Cosine, not cos. It's cosine. All right. And tangent. Tangent. It's tangent. All right. So you should know how to spell all those. Okay. So these are the three trig functions of acute angles. So where did the other three come from? All right, here they come. The other three are the reciprocal functions. And they have a slightly different names. The reciprocal function of sine is cosecant. I'll write that out. S-E-C-A-N-T. Cosecant. We abbreviate it CSC, cosecant. Cosecant of theta is just the reciprocal of this ratio. Technically, the definition is 1 over that, yes. But can I just flip the fraction?
Yeah.
Yes. No. So R over Y. So it literally just flips your ratio. So the cosecant ratio would be hypotenuse over opposite. You flip those legs, okay?
It's like 9 to the negative 1.
No, it is not.
Oh, okay.
Yeah, it is not. That is different. Okay, the reciprocal of cosine is secant theta. S-E-C-A-N-T. Secant of theta. Again, just is the reciprocal, so just flips the fraction. That's going to be R over X. And then this is the only one that really makes sense. The reciprocal of tangent is cotangent.
I think it's
I know. COT is how we abbreviate that. Cotangent.
Is it X over Y?
It is X over Y.
Heck, yeah.
Okay. So your job is to remember which goes with which. Sine is the reciprocal of cosecant. Cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent, and vice versa. So about that, they each have a co. Sine with cosecant. Cosine with secant. All right? Tangent, co-tangent. So they each have a co that goes along. Okay? So keep that straight. And that's these are the 6 trig functions. Your job is to really know these 3. Then the other 3 are easy to get, right? Question.
On the calculator, is it just like send to the negative?
It is not. Yeah. Yeah. So that means inverse. So that's an entirely different function on your calculator. Yeah. So I will show you how to do that in a couple of days. So you won't need it. I'll show you how to do it on your calculators. No. Yeah. I'll show you later. You don't need to know that right now. All right. Example 1. Find the value of the 6 trigonometric functions of angle theta in the figure. Find the value of the 6 trig functions of angle theta. According to angle theta is really the key. So you need to draw a picture, and you should have that angle theta labeled. I wonder whose phone that was. All right. What you're going to do right now is like 90% of the trig you need to know how to do. So pay attention. Okay. Looking at this triangle, if this is angle theta and this is our right angle, what label can I give this side? Hypotenuse. And then what would we label this side?
That's the opposite.
This is opposite. The opposite of angle theta, very important, which leaves the 2 as adjacent. Adjacent. Okay. So I have the length here of this hypotenuse is radical 5. The length of our adjacent side is 2. What do you suppose we need to do?
We need to find the opposite.
We need to find the length of the third side. So the first step is find the third side of the triangle. How are we going to find the third side of the triangle? Pythagorean theorem. Very good. The Pythagorean theorem is a squared plus b squared equals c squared. The important part is c. What does c represent? Hypotenuse. Always. So make sure that you're always equal to the hypotenuse squared. We don't care about the other things. So I'm just going to call this x, mostly because it's horizontal, so that's the x direction for me. All right, so x squared plus 2 squared equals my hypotenuse squared. X squared plus 4 equals 5. Good. So we're going to subtract the 4. And then we do a square root. So we get x equals 1. The square root of 1 is 1. Now, normally when you take a square root, you have to remember plus or minus, right? Good. So this is a triangle in space, and lengths can't be negative. And so we actually don't care about the negatives at this time. Okay. All right. Let's catch that. It can be, actually. It's just a very small triangle then, isn't it? Okay. So the second part are all of our ratios then. So we want to find the sine ratio according to theta, the cosine ratio according to theta, and the tangent ratio according to theta. Do not write sine without theta. Okay? Because it's meaningless. The angle is the most important thing. So the sine ratio, according to angle theta, sine ratio is what over what? Opposite over hypotenuse. So that's going to be?
1 over
1 over radical 5.
1 over radical 5 is great. Except they're going to rationalize most of the time. So how do you rationalize? Multiply top and bottom by radical 5, which is going to give me?
Radical 5 over 5.
Over 5. Very good. Radical 5 over 5. Good. In calculus, you don't have to rationalize. That's the gift I will give you to be a calculus. Okay. So I think that these are fine, and we'll actually use this most of the time. But answers are usually rationalized. Okay, what is the cosine ratio according to angle theta? Adjacent over hypotenuse becomes 2 over radical 5, which rationalizes to become?
2 radical 5 over 5.
Good. 2 radical 5 over 5. All right. The tangent ratio according to angle theta is opposite over adjacent. Opposite over adjacent is going to be 1/2, which is a great answer. Okay, so those are the 3 trig ratios. What are the other 3? Cosecant theta, secant theta, and cotangent of theta.
If you're doing cosecant, do you have to rationalize it again?
So, good question. I'm going to go back to this guy.
Just use that thing.
Yeah, so I'm going to use this one, the pre-rationalized answer, and flip that. If you flip 1 over radical 5, it becomes radical 5. Hey, that was better. And yes, if you use this one, you have to re-rationalize and reduce. Really annoying. All right, so secant is the reciprocal of cosine. So again, I'm going to look at my pre-rationalized answer, flip that, and get radical 5 over 2. And then tangent, I can flip that, and it becomes 2 over 1, which is just 2. Okay, so really easy to do those, ladies and gentlemen. Do you have questions for me?
Is that it?
That's it.
Yeah.